Okay.
I'll try that on YouTube now.
So tonight we're going to kind of be talking about the Internet of Things. It is essentially kind of like a rebranding of some existing technology, and there's been a whole lot of infrastructure and stuff kind of built around it. And so we'll kind of go. My name is Wes. I think everyone kind of knows who I am. If you're out there on the interwebs, you can follow me on Twitter. Always looking for new friends. So kind of what we'll talk about tonight is like we'll go over what is IoT, some of the tools of the trade, and some of those tools are kind of some of the technology and stuff I've specifically played with. We'll kind of do like a live coding demo on a kind of IoT device, essentially kind of like the Hello World version of IoT. And then I'll have some final thoughts, and we can just open it up for like questions and discussions. So, what is IoT? This is a really complicated definition. Internet of Things refers to an ever-growing network of physical objects that feature an IP address for internet connectivity, and the communication that occurs between these objects, and yeah, blah, 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 blah. Really complicated. Kind of what that really means is all the things are connected to the internet all the time, anywhere. Kind of what you can kind of start to think of how that affects your life is that literally everything will have some type of internet connectivity, and you will be able to control things with your phone. And this is just
internet microwave.
You want an internet microwave? Yeah. This stuff's getting really cool. So these are some of the kind of like the consumer-facing IoT devices that are kind of on the market right now. I know there are some folks in here that have, we have a Nest user, and then Josh back there has another type of thermostat that's connected. There's cameras, there's washing machines. There's actually a Brita filter now that is also internet connected, and it will tell you when it needs to be replaced. Like the filter needs to be replaced. And then like, you know, there are refrigerators that will keep track of what's in there and will build a grocery list for you based off of like whether or not you have enough milk or butter and stuff like that. There's a Keurig machine now that you can be like, all right, make me my coffee in the morning, robot, and it'll do it. And then, you know, hot water heaters. And so pretty much all the appliances in your house will kind of slowly start becoming connected to the internet. Whether or not that is a good thing, like I don't know if you need a washer and dryer connected, or your coffee machine. Really cool stuff. But then there's also applications that are kind of like in industry and an enterprise, and so you can kind of think of like a smart windmill that knows how much power that it is producing and how much power is being consumed from the network or like from the power grid, and be able to adjust itself to optimize around current needs. Kind of same thing you can kind of think of with like gas pumps. So being able to kind of in real time know the entire logistics and consumption of all of your gas stations, and being able to kind of plan proactively around what you need to buy to fill up your tanks. And we're like already starting to get to like what we have like smart power grids, to where you have companies like Nest who are kind of trying to take some of the user data and work with power companies to be able to optimize some of the loads and stuff across the power grid. And so technology like this has kind of existed within industry for a little while, but they've kind of starting to standardize it. And as we have figured out that industry hasn't necessarily done it, it's one of the most hackable things that are out there now, and so kind of standardizing some of that and bringing a little bit tighter security model within that. So we'll kind of talk about some of the numbers. So I pulled some of these next couple of graphs off of a comprehensive data thing. I think it was one of the business magazines, I don't remember now. But you can go down here, this little bit.ly link, to kind of check that out afterwards. They have a whole bunch of numbers there that kind of explain the market and what's going on. But as you can tell, it's, you know, it is already a 15, 16, maybe even a $20 billion market, and it's expected over the next 5 or 10 years to get up over 50 and even into the 75 million. So it's kind of a high growth rate market. And within that, you expect to have just an ever increasing amount of devices that are connected to it. As far as some of the industries and some of the applications that kind of happen that will kind of come online with this, This is kind of a heat map that they've kind of broken down by industry and application. A lot of it is around logistics and being able to track parcels and equipment and know about the status of the equipment as it's coming online. And then also, like we talked earlier about the consumer goods, and so everything that will be in your personal life will start to be connected, which is kind of crazy. So how does this affect you? Essentially connect all the things, like that's what's going to happen, and so you'll be able to control everything from your phone, and all of your devices will end up starting to talk to each other. So like everything kind of pinging a particular set of grid. Earlier this year, we had a large attack that kind of took down essentially the eastern seaboard. We had that trouble at Randall. We had trouble with it at Brewery Buddy. And it is essentially all of these devices, as we start to figure out the security model, we're essentially going from like everyone having like 1 or 2 connected devices to being able to have like 20 or 30 connected devices. And so that just kind of blows up the amount of devices that can be hacked. And so Russian and China hackers are creating botnets out of these IoT devices now, and are using them to attack strategic resources. And so that is a really big concern and something that is kind of one of on the forefront of some of the IoT discussion right now. So we'll kind of jump into kind of what it looks like to kind of build your own IoT device. And so essentially pretty much like what that looks like is you have a little board like this guy right here, and it connects to the internet through a cloud, because that's how you connect to the internet now. And then it connects to some set of servers, and they communicate back and forth, so you can keep essentially state or like what the device is doing in both places. So some of the devices that you can see and use as you kind of start developing some of your own kind of platforms and technologies. The first one on the right is made by a company called Particle, and it's called the Electron, and it connects over 3G to be able to talk to things. You can do stuff with the Raspberry Pi. The Onion is a really cool development platform, and it is like literally this big, and so you can put it into places where you would never be able to put normal boards. This other one is kind of a Bluetooth Wi-Fi board. It's made by a company called Red Bear, and it's called the Duo. It's kind of a neat little board. And then Arduino and some of the other companies have started making IoT boards as well, and so I could have probably filled up 2 or 3 screens of all the devices that are out there, but I kind of picked some of the ones that I see people use a lot. As far as like what we use, there's an alternate company that kind of creates a competing board, and it's called a company called Hologram, and they're also provide a really good service. And so you have a board and you need it to talk to something. And so what does that look like? I think every company out there is starting to kind of get into that game, and they all kind of do things differently. So AWS, like Amazon, Google, Microsoft, Oracle, IBM, and then there's all these kind of like small little companies that have started coming up that do stuff very specific within IoT, and provide like the Hologram and Particle, like they specialize in creating like 3G and 4G connected boards, which is kind of cool. So before we kind of start jumping into the code, we'll kind of go over some of the big points of what we'll be doing. And so if you guys were at Holland's talk last month with using processing, it kind of has like the same type of stuff that you would use there. So you have like the idea of global variables. You have like a little place right here for you to do some of like the initial initialization. That was a redundant, and then you kind of have like your runtime event loop that just kind of constantly loops over itself. And so just like the processing environment, you have kind of some functions and helpers and stuff that are kind of built into your environment to kind of help you facilitate things. And so in this particular case, We have defined what will end up being a pin ID, and we will set this pin ID to kind of be an output mode, so we can turn on and off the power that goes across it, and then we just constantly write it to high, or in this particular case, what that means is on. So we'll kind of jump into kind of doing some of the Hello World's examples for this particular setup. I do have all this stuff on GitHub, so if you want to go check it out later. It also has links to the presentation, and when we get the live stream done, I'll link it there if you need to go back to it. And it has kind of links to all the resources for this particular board setup. So we'll kind of just hop into part of when I can show you some of what they do. So they're kind of an IoT platform. They are really trying to own kind of the hardware side of it, but they do provide like a cell service. And so you essentially have a plan like you do with your cell phone, where you pay monthly for so many megabytes of data transfer. I think like I pay like $2 or $3 a month for it, and it's like all the messages that I can send back and forth between the device and the service. They do provide some other pieces of hardware. I don't know what the best place to go. We'll just go to shop now. So they provide like a Wi-Fi development board, like a cell board, and they kind of they build smaller ones. And what's really cool about this platform is that if you want to develop your own board, you can incorporate their firmware into yours and utilize their service as if it were one that you wrote yourself. And in this particular case, this Red Bear is one of those companies that are not part of Particle, but have a board that runs on their service. And so they have like neat little kits and everything that you can buy, like asset tracking kits, to where you can essentially have a GPS module that hooks up to it and send the location of that device to your service like every couple of seconds, so you can kind of know where your device is at all times. So we'll kind of hop in. We're gonna make this light blink. This is kind of the hello world of kind of your basic electronic board, and then we'll modify it so that it will blink over 3G.
Wes, can you talk about?
Pull up the. So it's kind of a really basic setup. This is not the board that we're using, but we have an LED, is what you can tell right here. We have a resistor just to kind of make sure our voltage is within the acceptable range of the LED. We have the board, and in this case, I also have an antenna that is on it for your cell phone, for your cell signal. And so you can run software on this like you would like your Raspberry Pi or Arduino, or you can also kind of connect it to the Particle service and interact with it through their API and other things. So hopefully it is not already running on it.
Another question.
Yep.
What processor's on the board?
That's a good question.
Don't worry about it then.
Yeah, we'll come back and look at the hardware and stuff afterwards. So we're gonna kind of pop over here, and so when you create a new, so they have a web IDE, and they also have one so you can do your programming locally. They call it Particle Dev. And so if you've ever used the Atom editor, it's just a modified Atom editor, and it kind of gives you the same functionality. Dang it, go away. But we're going to do it in the cloud, so I can push all the code to it over the network. All right. So we're going to start by defining our LED, which I think is going to be on C0. And so if you kind of look at some of the boards, you can see like there's these little numbers and everything to it along the side of it. And so these are just kind of pins that allow you to read and write information. And so in this particular case, we're using this C0 one, or C9. And what we'll do is essentially tell it to go high, provide power, wait a couple of seconds, and then kind of power that port off. And so I think it was called pin mode. It's been a while. Yeah. So we're going to do pin mode, LED 1, and we're going to say that it's an output. So you can also do inputs, so it will essentially kind of read. This one's digital, so it will be like 0 or 1 if there's a voltage across it. They also have analog pins there, so you can kind of get a continuous, so like if you have something that looks like a sine wave or something like that, you can kind of get a continuous reading of that. And so we will do, I think it's right, yeah, because I'm lazy. And we'll copy and paste because that's what you do.
In your loop.
What's really bad is when you copy and paste and you do it across your entire. I'm already running on this, but you know, you can essentially come in here. Oh, I got to get over the title. LED sparked. Save it. And then this is kind of like if you've ever done anything with Arduino, you kind of have to verify it. What is it called? Delay. And so we'll save it again. And it works. It kind of, you get this little nice verification down here that says, great, your code is great. And so now we can deploy it or flash it to our device. And so it gives you a couple of different ways of doing it. So you can do it over USB, or you can do it over the air. And so we're just going to do it over the air. And you won't see any change in this because it was already running the blinking light. All right, it's got it. It's booting. And there we go.
So I did notice a change. There was a blue LED on the board, and the separate LED they were flashing synchronously.
Yeah.
Now they're not.
Yeah. So there is an LED that's on here, and it is on pin D7. So if we wanted to kind of do that again, what we'll do is say LED 2, D7, and we'll kind of set it up just like we've done the other one. No. Oh, they have errors in their console.
Now, how would you write a separate delay potentially for the second set? Could you write?
So you wanted
add the
it to
delay
be
between the two? Just
So
you
you
can tell
could.
the offset.
Yeah.
Basically.
So we could do something like we will stagger them. We'll just have them a second apiece.
He wants. I want to see it. That's all. Yeah, that looks good.
So they should go like
Yeah.
something like that.
Because they were synchronous before. I just want to make sure they're not synchronous again.
Yeah. So we'll verify this and make sure I haven't copied and pasted anything wrong.
And you can you flash, or do you have to do it differently?
I have to flash it every time there's a code
No, I mean
change.
USB flash.
Oh, I don't, like I would have to download the firmware and use, like, essentially what happens is they'll build a custom firmware for you based off of the code that you've written. They have a command line tool that you can push that code to it. I don't use this enough, so I don't mind taking up some of my data. All right, it's doing its thing. We're getting it. It's about to start.
Oh, bam. I love it.
Yeah.
Pause it.
And so, like with every great piece of software, there's supposed to be really good resources with it, and so they have like a huge reference library, so you can kind of come in and kind of see all of the things that you can do with it. So the next thing that we'll start doing is what they call cloud functions, and this is how we'll control it over 3G. But there's other things, and so like here's some of the documentation on like the pin mode and how you kind of do that. You can get the pin mode. You know, there's digital write, read, analog write and read, and so Brian was talking about pulse width modulation, and so you can set that up on an analog or a digital port and be able to facilitate that through this board as well. And so it also has like Wi-Fi connections and serials and timers and servo libraries and LED libraries. There's a math library, didn't know that. That's nice. And so we'll kind of just jump over into the next one. I'm going to have to cheat with this one because I'm not as familiar with what we're about to do. Will allow you to do that. So the particle, the cloud functions, they will give your function a string and they expect a number back. And so we'll go ahead and do that. And so we'll do like toggle LED. And so it will be a string and it will be a command. And so we're just going to send the command on and off. So we're going to check to see if the command equals on or if the command equals off. And if that breaks, we're just going to return this -1. So this is kind of the common response for it, like an error. I didn't get what I wanted. And so here we're going to return a 0 because it's off, and we'll return a 1 here because it is on. So what we'll do is kind of what we did earlier. I'm going to have to copy and paste because I forgot the keyword again. LED 1, high.
It was a T.
Damn it. Where? Oh, yeah. And we'll do LED 2. And then if it's off, we will set it to low or off. So this is all all of the basic code that you need for being able to do this. The next piece is that we're going to need to register this function so that the cloud knows about it. And so I'm just going to grab it because that's what you do. And because there's already a program running on it, I will go ahead and make sure during the setup everything is turned off for us. And so now this is great. We'll see if it builds. No.
You have
And all right, while it's doing its thing, there's this little web page, and it's also in the repository if you guys want to look at it. But it is creatively a form that has buttons that you can say on and off. So we will open up this in the code editor so you guys can see it. So all it is you make a post request to this thing, and so this is where the LED piece comes in. So this is the device ID, and this is kind of my access token to be able to talk to the Yeah, I'm going to refresh. I see you looking at me right now. These will all be refreshed at the end of the talk. And all it is just like a little simple HTML form that has on and off in it. All right, we're still getting the spinning wheel of death.
Oh, there you go.
There we go, it's on, great. And so it kind of has like a standard response for you as well. So you can see this is what that function on the device return, which is 1. And so we can go back and we can kind of hit LED off, and it will take its time again, and it turned the LED off. And so this is kind of just like, this is what basic IoT programming is. There's some type of endpoint that you define, and so we can kind of hop back over here into the kind of the reference documentation. So we use what they are called cloud functions, and so you can have up to 15 cloud functions for your device, and so that allows your device to do 15 different things if you want it to, or a combination of things. And so all you do is kind of give it a keyword name that it will know, the function name, and then you write what you want it to do. So you can do everything from toggling LEDs to doing servos to, what are some of the other things that you did?
That's mostly what I did, but I was thinking you could also log things like you track temperature.
Yeah. So they have this console that's also part of it, which is not particularly interesting, but it kind of gives you, come on, give me all of my old data. All right. Well, I actually had a neat little thing because Josh and I were working on a project. Well, it will actually, there's an integration with this with Google Maps, and so it will actually, there's like a little program, I can show it to you, I think. No. All right, well it is no longer there. Let's see if this is But essentially you can have it so that you can triangulate your position based off of the cell towers that you're connected to, and it will give back an estimated Latin long, and then essentially, like, if you ever seen like that little circumference, like kind of error radius that you're supposed to be in, you can do stuff like that with it. They have a ton of great examples, like in their documentation. There's a great tutorial section that kind of can walk you through all of that. They have integrations with Google, Azure, and there are kind of some secondary things that you can do to hook into other services. Webhooks, if you're interested in doing it, they have some firmware and libraries that allow you to run this stuff on your Raspberry Pi. And so this is just kind of almost like a middleman platform that essentially handles the security between your device and then their service, and then you can integrate your service into their service, so in case you wanted to, like, when you sneeze, you want like your web page to like blink or something, you could do stuff like that. They have
Finally.
Yeah. And so some of these other like little things that they have in the tutorial, so you come into here to encode examples, and so we essentially did the first two tonight. The one is the kind of the basic blink the LED. Then they have one controlling it over the net, and so the code that I have in the Git repository has a little bit slimmed down comments in it, but if you really want to know what stuff like photoresistors, and so if you wanted to be able to have something like where you like run your hand over it and like your Philips Hue light come on, like you could do stuff like that, like.
Or you can see if you left the lights on when you went out to dinner.
Yeah. You could put a temperature sensor on it and hook it up and set it on like the side of your stove to see if your stove was on or left on.
No, the laundry's done.
That's a little more complicated, but we could probably do it. You could get like one of the vibration sensors, and if it was not, when it kind of settled, it would be like your laundry's done.
It makes the sound. It sings to you.
You could listen for the sound as well. You can hook up a mic to it.
I actually hooked up a reed switch to one of these to tell when my garage door was open or closed,
Yeah.
and gave it the output to open or.
Nice.
This looks like a much easier way than what I had though.
Yeah. So in this case, they're using the photoresistor to do a motion detector, which is kind of cool. So the only thing that a photoresistor does is its voltage across it changes based off of how much light is hitting it. Or I guess its resistance changes based off of how much light hits it. And so it's hooked up to some of the analog, and so you can actually see how much light is hitting it or how little light is hitting it. And so that's how they're kind of doing that.
It's cool that you can control the sensitivity of that.
Oh, you know, so you don't control it, you just read the, like, how much light is hitting it.
Well, I mean, based upon that.
Yeah, you can do it, yeah, for sure. And so, I think this is too long of a name. I think you're limited to like 12 or 20
I
characters.
think it's at 12.
And so there's a whole bunch of different applications for it. They have, it's like an example with IFTTT, like the webhooks, all sorts of great things that you can do with this pretty simply out of the box. So we will hop back over. Good, I didn't close it. So my final thoughts. IoT is really cool. It's going to change the way that we do everything, like blinking LEDs. Like only a couple of years ago, you could only blink an LED right on the device. You couldn't control it over the internet, and now you can. That's changed me completely. It's allowed me to do this talk tonight. But like on a more serious note, like there are some serious concerns around it as far as some of the security aspects of it, and you know, there's a new Amazon device that is essentially allows you to, it's like a camera and it has like a little screen and everything, and there's not like an on-camera indicator. That's an IoT device, and if that doesn't scare the shit out of you, like someone always being able to watch you and you not being able to know about it, being able to turn off your hot water heater, like that would be like a great prank, or a really awful hack. So there's all these concerns as this stuff becomes more part of your life, our life every day, but it also has an opportunity to really help automate many aspects of what you do and kind of give you a little bit more robust environment. So with that, questions, discussions, we can look up processor type on the board.
I do want to state before the certainly get to the questions, but what's great though about the concerns is it creates this new industry of how do we protect these things because it's inevitable. And it's nice to get into this entry level and know what the concerns are and maybe even put your foot in the door to potentially achieve this stuff because it is the future.
Yeah,
there's no way around it.
100%. So what I'm going to do, I'll do that in a little bit. So let me see. Sorry, I got too many things. This is how I segment my work.
So Wes, there's different levels of connectivity in different areas, different cell networks and things like that. So with, I guess, some of the things that you're seeing here, what do you think, like in maybe some of the more rural areas, we're in Alabama, like sometimes there's dead spots. Yeah. Is there a way to maybe piggyback off multiple cell towers?
So you can do some of that. So when I was initially running that Google Maps location thing, I was in a place to where I didn't have enough cell phone towers to actually be able to get any information back from them.
I have an additional question on that. Do they make boards that would accept SIMs from carriers? So like if we could do Google Fi on it, that could bounce off multiple carriers.
So this uses like I think T-Mobile's network, which is like a conglomeration of every network to some extent. So between Particle and Hologram, like they provide their own SIM card, and then you can use that SIM card in other devices. Yeah. I've never seen it go from like a traditional like cell OEM SIM card to put it in. I haven't seen that yet. It could be. I just don't know if their particular infrastructure or like the way that they communicate with it is set up that way.
Yeah, I mean, there are other boards that you can put SIM cards in, and you may just not be able to work as well with their ecosystem, but you can work with other ecosystems.
Mm-hmm.
Some of that middling that particle does seems to be preferable over just having it.
Yeah, but there's dozens of companies that have middle things like that too.
Yeah.
So.
All right, hardware. If you see tech specs up there somewhere, stop it.
Oh, there you go. It
Yeah.
said ARM Cortex M3.
Yep. So this little setup, it was actually kind of nice. I bought one of the kits with it, and it had kind of this little breadboard that came with it, the antenna. It has a battery that came with it, and I kind of wanted to do it with the battery so it wouldn't look like I was doing it over USB, but I lost it. I don't know where it's at right now.
That leads into a new question. Could you make it to where if you ever lost internet, like there's some local storage that kind of logs stuff?
Yeah, so
you
you
know what's
have
going on when you don't have internet?
so you have a little bit of a
Yeah, it says right there 1 meg flash.
yeah. You could also have it set up to where if you needed to like fell over to like a different thing like Wi-Fi or something like that. You know, let me see if I can pull up that that data. And so the actual cell part of IoT is not, they don't expect it to be Forbes, is where this came from. So you can see cell IoT is not going to, they don't expect it to be a large part of the market. Most of the devices and stuff are going to be Wi-Fi because they're at your house. And so I would probably suspect that most of the devices that you will buy or see in industry will be Wi-Fi. It'll probably be some of the rare use cases of like having like a hunting like camera and you wanted to like send that back to your house afterwards.
Or like GPS tracking.
GPS tracking, like there's, like I said, the particle has like an asset tracking thing. And then also I have it, so if I wanted to, this is a neat use case of it, like, you know, I have that little OBD2 port reader that takes a bunch of different boards. One of the boards is actually this. And so I can send like real-time data from my car as I'm driving down the road to particle that I could then throw into a database for processing later. Or I could turn my car on remotely, which I don't know if I can do that. I don't know if my car's a little old.
I'm so freaked out that my car logs stuff on my dashboard now.
Yeah.
It's so weird out.
Yeah.
So does this particular board have built-in GPS, or is that an additional shield?
No, so the GPS that I tend to use is this little bitty module, and this board supports a whole bunch of things. So it supports like the CAN bus and a couple other buses for like your car and industry. It has a kind of a built-in module to allow you to do GPS, but you have to have an antenna for it. And so there's a cheap antenna that is used in a lot of things, and it's this little guy right here. So for $40 you can add accurate GPS to your device. And I actually, for one of my little OBD2 port readers, I actually have that on it, so you can, it's using the Red Bear. It works over Bluetooth.
Red Bear's got a lot of great accessories.
So what?
So the Red Bear's got so many great accessories.
Yeah.
I love it.
So then how would the GPS receiver connect to the particle board?
There is a secondary board, so let me go to.
Boards all the way down.
Yeah, just stack them up. That's what shields
No,
are.
I
right?
mean, there are GPS receivers you can buy for like $7 from China
Yeah.
that just hook up to the pins
Oh,
with
yeah.
wires and then write your program to read them. So hooking up the GPS is actually pretty easy.
But they don't support this bear anymore. That's terrible. Inside of this little board, there's like a little pin adapter that you can plug in, and then there's other, you don't have to use this one in particular. Like he was saying, there are GPS modules that come as their own shield. That have kind of like pinouts and.
Well, it's even ones like that EM506 that just speaks over a certain serial protocol, so that would be easy to read there with a little bit of programming.
Yeah.
I mean, the thing is, it's a board with all these pins out designed for you to add your own stuff to.
Right.
So
You could do little bitty ones. I don't connect to floors on this. No. So yeah.
Pretty cool.
So yeah, if you want to come back and afterwards and check some of this out, I have, like I said, everything on GitHub, kind of linked out all the resources, and then the talk, and then this will also link to the live stream whenever that ends, if you want to go back.
The recorded stream.
Recording the stream. So yeah, any more questions, or if not, we will chill for a little bit.
Thanks,